Hello everyone, in this video let's go through the quotient law of exponents and some of the problems associated with it. So the quotient law of exponents states that when powers with the same bases are being divided, the quotient will be given by the same base raised to the difference of the exponent. So a raised to r divided by a raised to s is equal to a raised to r minus s. And this is how we express this quotient law in the fractional form, which is a raised to r over a raised to s is equals to a raised to r minus s. Let's look at some example. 2 raised to 5 divided by 2 raised to 2. So how much is this? Since the power with the same bases are being divided, so this will be equals to, write the same base and you subtract the exponent, that is 5 minus 2, which equals to 2 raised to 3. And 2 raised to 3 equals 8. Now let's check it once if this is really equals to 8. 2 raised to 5 means 2 times 2 times 2 times 2 times 2. That is 2 repeatedly multiplied for 5 times, which equals 32. And 2 raised to 2 means 2 times 2. That is 2 multiplied for 2 times, which equals 4. Now 32 divided by 4 give us 8. So yes, 2 raised to 5 divided by 2 raised to 2 is exactly equals to 2 raised to 3. That is 8. Another example, 4 raised to 5 divided by 4 raised to 3. Since the power with the same base are being divided, this equals to, write the same base and you subtract the exponent, that is 5 minus 3, which equals 4 raised to 2. 4 raised to 2 is 16. Now let's check if this is really equals to 16. 4 raised to 5 means 4 multiplied for 5 times, and this is equals to 1024. 4 raised to 3 means 4 multiplied for 3 times, which equals to 64. And when we divide 1024 by 64, it exactly gives us 16. So yes, 4 raised to 5 divided by 4 raised to 3 is equals to 4 raised to 2. Another example, negative 3 raised to 5 divided by negative 3 raised to negative 4. Since the base are same, so write the same base and now you just subtract the exponent, that is 5 minus minus 4, which equals to negative 3 raised to 5 minus times minus 4 means plus 4, and this gives us minus 3 raised to 9. So this is equals to minus 3 raised to 9. Another example, 3 raised to 15 divided by 3 raised to 5 divided by 3 raised to 2. Since the base are the same, so write the same base and you now subtract the exponents. So 15 minus 5 minus 2, and this is equals to 3 raised to 8. One more example, x raised to 25 divided by x raised to negative 5 divided by x raised to 8. Since the base are same, so write the same base and now you subtract this exponent. That is 25 minus minus 5 minus 8, which equals to x raised to 25 minus times minus 5 means plus 5 minus 8. And this equals to x raised to 22. Now let's look at this problem. It says find the value of a in each. So let's solve part A. On this side of the equation, power with the same base are being divided. So write the same base and subtract this exponent, that is 10 minus 5, which equals to 7 raised to a on the other side of the equation. And this equals to 7 raised to 10 minus 5 is 5, which equals to 7 raised to a. Since the base on the two sides are equal, therefore exponent on the two sides must also be equal. So which means a must be equals to 5. Let's solve part B. On this side of the equation, power with the same bases are being divided. So write the same base and you subtract the exponent, that is 27 minus a, which equals to 3 raised to 20 on the other side. Since the base are same, so exponent must also be equal. So 27 minus a is equals to 20. Now take this minus a on the other side of the equation, which becomes 27 equals to 20 plus a. So when you take this minus a on the other side of the equation, it becomes plus a. Now bring this plus 20 on the other side of the equation, which becomes 27 minus 20 equals to a. Plus 20 becomes minus 20 when you take it on the other side of the equation. So a is equals to 27 minus 20 means 7. Let's solve part C. Since the power with the same base are being divided, so write the same base and subtract the exponent, that is 23 minus 20, which equals a raised to 3 on the other side. Now this becomes x raised to 23 minus 20 equals 3, which equals a raised to 3 on the other side. Since the exponent on the two sides are equal, therefore the base on the two sides must also be equal. So a must be equals to x. Now let's look at this another problem which says express each in a single power. So we need to simplify this. So let's simplify part A. In this expression, 5 is repeated for 8 times in the numerator. So the numerator becomes 5 raised to 8 divided by, and the 5 is repeated for 4 times in the denominator, which becomes 5 raised to 4. And this equals to, since the power with the same base are being divided, so write the same base and subtract the exponent, that is 8 minus 4, which equals 5 raised to 4, which equals 625. Now let's solve part B. A is repeated for 3 times in the numerator. So the numerator becomes a raised to 3 divided by, and a is repeated for 6 times in the denominator, which becomes a raised to 6. Since the power with the same base are being divided, so this equals to, write the same base and subtract the exponent, that is 3 minus 6, which equals to a raised to minus 3. Now let's look at this problem which says write 5 over 8 in each way. Let's solve part A which says express 5 over 8 as a question of other powers of 5. So there are infinite ways to express this. 5 raised to 8 can be written as 5 raised to 10 divided by 5 raised to 2. The base are same, and when you subtract this exponent you still get 8. Another way to express is 5 raised to 15 divided by 5 raised to 7. Since the base are same, and when you subtract 15 minus 7 you still get 8. Another way could be 5 raised to 20 divided by 5 raised to 10 divided by 5 raised to 2. Another way could be 5 raised to 100 divided by 5 raised to 80 divided by 5 raised to 12. The base are same, that is 5, and when you subtract 100 minus 80 minus 12 we still get 8. Now let's solve part B which says express 5 over 8 as a power of 25. So I can write 5 over 8 as 5 repeatedly multiplied for 8 times. So I can still write this as 5 times 5 means 25 times, again 5 times 5 means 25 times this 5 times 5 still gives 25 times 5 times 5 here equals 25. Since 25 is repeatedly multiplied for 4 times, so I can write this as 25 raised to 4. So 5 raised to 8 is exactly equals to 25 raised to 4. Now let's solve for part C which says express 5 over 8 as a question of powers of 25. We have known that 5 over 8 is equals to 25 raised to 4. So I can write this as 25 raised to 6 divided by 25 raised to 2. Base is still 25, and when you subtract this exponent 6 minus 2 you still get 4. Another way to express this would be 25 raised to 10 divided by 25 raised to 6. Still another way could be 25 raised to 100 divided by 25 raised to 90 divided by 25 raised to 6. Another way to express could be 25 raised to negative 4 divided by 25 raised to negative 8. So there are infinite ways to express this 5 over 8 as a question of other powers of 25. I hope this video helps you all.